Welcome to the Solutionology Podcast. Today, we're going to talk about the digital mindset.
So we have a bunch of conversation today. What is the digital mindset? How do we use it? Where do we see it adding value to the design process or any process, really? It's about exploring the journey.
Spoiler alert, this isn't about computers.
Yeah, it is not about computers.
So we are talking about a mindset that we apply a digital process to. And we're going to go through we're going to have lots of great conversations. We're going to go through the pain points. We're going to talk about why we apply it and the benefits that we see for applications of all sorts.
Thank you for joining us on the journey today.
Have fun. So what is a digital mindset from your perspective?
A digital mindset is a way for us to stay flexible throughout a process, a project, solving a problem, so that as we're going through that process, we're not locked into a preconceived bias. It's about staying flexible throughout the journey. It's not a 1 and 0 sort of software. It's not controlled within a program or a computer, but it's using the sort of the practicality of how computers work. The digital side of a computer, we can save a new file, we can rewrite, we can update a revision digitally. It's a matter of fact of changing a very small component of it, and we have control over the process. So that's where, as we're talking about digital mindset, it's about taking the ability to make rapid changes and store them in a quick and lightweight format like digital, where we're not carving out, for instance, a chunk of wood into a circle. For me to go out and recarve that, I've got to start from square one. If this was a digital component, I could change that circle with a matter of resaving or modifying a parameter.
So really we're talking about the difference between digital and analog, where an analog device is generally hard-coded. In order to change the output of an analog device, the device needs to be reconfigured. And in the case of a digital device, that device can be recoded without reconfiguring the hardware. So it could be adapted to have different outputs without completely re-engineering or changing the device.
That's right.
And device can be software, it can be hardware, it can be 3D printed products, it could be injection molded products. So it doesn't have to be digital in order to have a digital mindset applied. It just has to be constructed so that it can be adapted for the flexibility that's desired.
That's right, yeah. And you're going to share an excerpt that describes this in a different way.
I found a great excerpt from a Harvard Business Review article that talks a little bit about digital mindset. Now, this article is about a digital mindset. We'll include the link. And it talks about the digital mindset more in an organizational and IT infrastructure way, but I believe that this language that I'll share is applicable and 100% applicable to product design, to hardware design, to what we're doing as well. The subtitle of this section within the article is Change as a Constant. Organizations move from a current state to a transitional state and then to a future state. The transitional state is typically considered to be a fixed period of time in which an organization shifts from familiar structures to new ones. In a digitally driven world, there is no endpoint to the transitional phase. Digital tools change constantly and rapidly. Organizational structures must be continually tuned to make new use of data insights, and leaders must continue to keep working to bring employees along as the organization evolves. Reconceiving of change as a constant process of transitioning rather than an activity that occurs between states is what's key. So we're really talking about this constant state of evolution and transition being the norm rather than a point in time that gets us to the end result.
Yeah. I think the most obvious way that we see that day to day is as you're pulling apart an assembly that you purchased. Maybe you bought a product, you dig in, and you find these little revision controls everywhere, Rev A, Rev C, where there's changes along the way we still have an end product. The end product's flexible, and these revisions are like the breadcrumbs that occur that help us track the change that has occurred.
And we see this most often, well, we do see this most often in the automotive world, partly because we're working on cars. But the automotive industry does such a great job at documenting their rev control on the parts because of their inventory management and providing replacement parts. But the automotive industry uses this extensively, constantly evolving the designs for a number of different reasons.
Applying this digital mindset to the development phase, for instance, with the same sort of controls in place where you're able to break up, document, and revision control products through the development phase is probably one of the biggest areas of pain that we experience, associating when are we applying digital mindset and when are we not.
Is it fair to say that pain is because if you don't incorporate a digital mindset into the design of a 3D model, for example, then that results in pain?
Yes, and I think that pain is best described as if someone has the perspective that when they complete a revision or a design, that it's done. This is final. This is being released. There's no more changes. I never have to look at this component again, because once I'm done with it, it's doing its thing. Being in that sort of mindset prevents us from being methodical about the journey and setting up aspects of that product in a way that allows for future adjustments in areas that we know are critical for the functional use of the product.
So you're saying that if I'm designing a product and then I make a revision or I design a component and just assume that component is finished forever, that's where the pain starts from, because it's never finished forever, and it's going to get revised in the future, and I've got to design that model so that it can be revised easily without being recreated from scratch. Is that right?
That's right. So if I came here today and I thought this was the last time I was ever going to walk in these shoes, I wouldn't care about the shoes. It's like, I know I'm going to get here, I'm going to take my shoes off, and I'm done. I don't have to wear them anymore. But if I come here knowing that I've got a 1,000-mile journey to travel after this and I've got to walk that journey, how I treat my shoes and what I do next is really critical.
So on the surface, thinking about this digital mindset and agile product development, going quickly through the different iterations, sounds easy. That's been talked about for a long period of time, but in our experience, it doesn't play out that way. You get to experience this more than I do as we work through different projects. We've talked about agile product development for a long time, but this digital mindset component's not been a key part of that in our experience.
What I've experienced is when most engineers or even product developers are given a problem, solve this problem, we all tend to take it whole. And we're not chopping up and deconstructing the problem into its finite components. And if you miss that step, if you design a whole product in the first go, and you've got all the features that are needed, you've got this heavily constrained geometry that's not very flexible. But if you're able to break it up into the critical aspects of that product and treat them both individually and as a whole, it allows you to look at them in a different lens.
I'm interested if you can apply that theory that you just talked about to this bottle. Tell me how that would change the design process for this bottle.
If I were a traditional designer and I was given the task of designing a bottle that was insulated, it needed to have a cap, it's got to hold liquid, it's got to be food safe, and it's got to be aesthetically pleasing from a marketing standpoint, most designers would approach this and they would start to create this outline of the geometry in total. It's like, I'm going to make this whole thing, and then I'm going to make these editable aspects of the product within a full feature tree. So it's going to have the threads, it's going to have the internal shell, the external shell, any internal components, like if it's wrapped in copper on the interior, all that's going to be contained essentially within one model. And the way to break this up is, let's look at the constraints, and then let's make sure we can cut these components of the bottle separately So as we're doing product iteration and prototyping, we can validate rapidly that one feature is meeting the requirement, and then all that comes together to produce the end product. So let's cut off the threads. Let's develop the threads and the opening so that it meets all the requirements. Whether or not the threads are tied to a volume of material or to hold a volume of liquid, it doesn't matter. The threads have a function to perform. They've got a thread to the cap, and maybe we need to make it so that someone can drink out of the lid, so it's got to be comfortable, ergonomic for drinking from. So it's about breaking it down to the small segments.
So I've seen this in a lot of your models. You'll end up with this bottle, for example, may be comprised of 10, 12, 15 different components. You've got each of those components that are designed separately in models that have smart feature trees. So they roll up, and they're drafted in the right order. They roll up in the right order. And then you've got the assembly, which is really the composition of those different components. And then that if you change a component, that changes the entire assembly. And so it's like they're all interdependent from each other, or interdependent together, and will update almost automatically based off of a revision that you may make in the thread design.
And where it's important to split that up is that it's likely that an aspect of a design, a feature of a product, is going to impact not all the departments, but specific departments. And to be able to share and get revision and feedback on that one part without worrying about the full piece is really critical. If we're dealing with the threads, we need to make sure that we can manufacture them and the cap fits. But it doesn't necessarily impact the aesthetics. It has to be pleasing, but the driving constraints there is the cap's got to fit and it's got to have an opening in it. So focusing on those, not letting the other aspects of the design persuade the change in that location.
Sounds simple.
It's not. No. Yeah, it's definitely not.
You make it sound simple.
The journey is about understanding the real problem that we're solving, pulling out anything that isn't critical, and distilling it down to a consumable form that allows us to rapidly iterate. A bottle in some examples may not be the best example that we can work with, because
that's fine. I was thirsty anyways.
The total geometry, it's not huge. If we're working in CAD with that geometry, for us to iterate and replace the digital file there, it's a small file.
Simple.
It's lightweight.
Yeah.
But as we deal with larger single part or multi-part complex components, we need a way to break that up, not only so we can validate the features, but so that we can work efficiently in the digital software, so that we can work in a segment of the design, we can iterate and improve, and then as we're working on the final assembly, we can manage the heavyweight aspect there, but we want to keep these segments as lightweight as possible on the journey.
Well, I appreciate that. The difference between heavyweight and lightweight models based off of the complexity of the parts, but I would argue that there's as much value in lightweight parts following that process, because what it allows you to do is create, in some cases, a family of products that are based off some of the same core components, but they can end up with children.
That's right.
So you can have for example, you could copy that threaded section, apply it to a different volume or different body, and it can adapt to that new model. So now you've got 15 or 20 different products that are based off of the majority of the same base components, but there are tweaks.
That's right.
And that's something that we've done through our mass customization development efforts, is developing a base product that is digitally drafted with a digital mindset, so that it can evolve through different specific configurations.
And if we're designing that bottle, if we fine-tune through production trials what that threaded cap should be like, we don't want to start from square one again, and we don't want to pull the dimensions off of that part. We want to use that revision that we created, and we want to be able to apply that to lots of different things. Different bottle sizes, different bottle widths. We want to use the same cap and threading feature. It's like, let's reuse the investment we've already made.
That really resonates with me, and it highlights this notion in the excerpt that I read, that the transition phase is perpetual. It's not temporal. So the transition phase is the future state, not just a point in time to get to the future state. And if we think that way in our product design and modeling, then the product will continue to evolve almost seamlessly, and it allows us to adapt it to different market segments, to different market conditions, and be able to do that without extensive rework.
And a short time to update, keeping things rapid turnaround.
This segment isn't about 3D printing, additive manufacturing, or digital manufacturing, but when you take that mindset, that really plays well with deploying technologies using digital manufacturing. And digital manufacturing is more than just 3D printing or additive. It's applying the digital mindset to the manufacturing method as well, and making that as adaptable and flexible as possible. We experience that today, of course, with additive manufacturing.
Tools like additive manufacturing put the pressure on us as designers to be more efficient and effective, which is really critical in when you have time-based scenarios where you have a release of a design that you need to get out by a date. For instance, in the medical field, preparing for a medical trial, those iterations have to be very efficient, and the designs have to be accurate, because we can't change the timeline. The client can't change the timeline. We have to be very responsive, and they need to be as well as they're doing design iteration.
You're mentioning medical device industry. That's a key industry that this sort of approach benefits dramatically. Digital mindset dramatically benefits the healthcare and medical device industries, but that's not the only place. So the more that this can be applied to all products that are being developed, the more that it has a dramatic cost, and not only dramatic impact, not only in the time to market, but also on reducing the overall cost of the project. Getting to the market sooner, you're able to capture more revenue faster, but you're also able to reduce the development costs and expenses that you would otherwise incur through these weeks and months of iterative timelines.
It's double-edged. We've got this timeline that we can shrink if we manage the mindset correctly, and we go through the development correctly. But at times, if the time to get to market is extending because of there's issues with the development, it's likely that you're cutting off features or components of that product in order to get to market on time. It's like, we're already late, we've got to rush this through, we got to forget about these features. And if we can shorten that up on the front end, and we can be really methodical within the design, we can get the features that are really required and have the most successful product for release.
So we're talking about this today because additive manufacturing is such an enabler for speed and acceleration that it starts to identify these other drawbacks or bottlenecks in the process that were otherwise masked by all the other delays. And so there's real opportunity to shift the mindset from an analog or traditional mindset to digital, to capture the benefits of additive manufacturing and then push the benefits of even traditional manufacturing methods.
But that doesn't it doesn't hide the fact that it is the transition from the analog to the digital mindset. It's not a straight journey. It takes a lot of work to have that shift in thought process in order to execute and not make it more cumbersome.
We've been applying a version of the digital mindset for a long time. And so you say it takes time to get there. Are we there? Have we arrived?
There is no there. It's a continual application of the process to the new tools that we're faced with.
The more you're able to apply the digital mindset, the more success and gain you'll get. It's not easy. You're never fully there. You're always improving it. And I think in my perspective of our experience, leveraging additive manufacturing and coupling that with a digital mindset really starts to highlight opportunities for improvement of the digital mindset, and also the gains that you can get from coupling those two rapid approaches together.
It's about identifying where are we going next, what does that include, and how do we get there? And then knowing that once we're there, we're going to talk about where we go next. What do we improve, and how do we get there?
I love it. Living in the world of digital manufacturing and continuing to expand our capabilities in the realm of the digital mindset, we get to refine every day. And as Brian said, we're not fully there yet. We have a lot of work to do. But we've seen enough successes and have demonstrated refinement of the process enough times that we're getting to the point where we're helping our clients build a digital mindset and then apply it through different programs and projects. So one of the next sessions we're going to be talking about is this new initiative that we've launched. That's an education-driven initiative, and primarily focused on helping others, helping clients adopt a digital mindset to improve their program's success.
And you're referencing this next step that we're taking, this next release that we're doing as part of this digital mindset that we manage internally. And we don't know what that looks like yet. We're continuing to revise and manage the change, the continuous change throughout this process. But we're on the journey, and you'll be learning from us in real time as well.
So our next episode, we believe, will be, and it could change, we believe will be the exploration of this education initiative that we're launching or have launched, at least in its beta form. And we're excited about it. This digital mindset has been something that's changed our lives as we live the product development life cycle and then also additive manufacturing. And we're excited about sharing that journey with others. We believe that it can have a significant impact on the success and outcome of programs. So we look forward to sharing more of our journey with you as we continue to learn and explore. Thanks for watching, and we'll see you soon.
See you soon.